for the last time this year? Anne's going on summer vacation too. Says find the acceleration, massless, frictionless pulley. This is our Atwood machine. One of the things I noticed, and I may have mentioned this to you, I noticed these two masses are nearly identical. This is almost balanced. Just a bet you got an acceleration less than 1. Certainly less than 2. Definitely would be less than 2. There's not going to be much acceleration here. This is a job for a free body diagram, although since they gave me a picture, I said M1G tension, M2G tension. Who's winning? The heavier mass. Don't let the shape of the mass fool you. I'm stealing diagrams from all over the place. Look at the actual numbers. M1 is heavier. So my equation is going to be winner minus loser plus winner minus loser equals M all A. I can stretch it out. Tension cancels. A is going to be M1G minus M2G all over M1 plus M2. If you just divided by M all on this line, I'm fine with that, but I'm showing you the separate steps that I give marks for. So it's going to be M1 21.3 times 9.8 minus 19.6 times 9.8 all over 21.3 plus, not times, 19.6. You need to be comfortable typing this into your calculator. So definitely brackets around the top, or use your fancy schmancy 2-level fraction button. 21.3 times 9.8 minus 19.6 times 9.8, close off the top, divided by bracket 21.3 plus 19.6. Look for typos. That looks good. That looks good. That looks good. Did y'all get 0.407? If you got that and put meters per second squared for the correct units, I would give you 4 out of 4. You'll notice, although acceleration is a vector, I'm not asking you for the direction. And the reason is I got one thing accelerating up and one thing accelerating down. There's more than one direction here. So typically I'm just asking you for the magnitude is what you're getting. Yes?
How many different questions did you get on the test?
I already finished saying that. Did you get here late? Okay, so you've got to get here on time to hear those things. Sorry, but a little snotty that way. Yeah, being a little mean. So otherwise, I would give you 1 mark for the main equation, 1 mark for realizing you had to divide by M to get the A by itself, M all to get the A by itself, 1 mark for the numbers, 1 mark for the answers. Yeah, that is 4 steps, 4 marks. Find the tension in the cord. I'm going to use, I guess I'll do it quickly both ways. So you can either go M1G minus tension equals M1A, or you could go tension minus M2G equals M2A. For an individual force, you do an individual mass equation. I'm going to solve the right one because it's a little easier to get the T by itself. Here you would swappy dance and you'll have M1G minus M1A equals T. Here I'm going to have tension equals M2A plus M2G. M2 was 19.6 times answer button plus, I'm running out of room, Mr. Duick. Let's see. I'm going to go straight to the answer here. 19.6 times answer button plus 19.6 times 9.8. Do y'all get 200? And I knew it was going to be a fairly big tension because 19.6 kilograms, that's about 50 pounds. About 50 pounds. There's about 100 pounds of mass on either end of this rope. This rope is feeling some tension. So I was expecting a fairly big answer here. So 200 would get you 3 out of 3 newtons because it's newtons. If you got the acceleration wrong, but you successfully went M2 times your answer plus M2G, or M1G minus M1 times your answer, I would give you 3 out of 3 for part 2. So if you ever come to a question on the test and you can't remember how to do part A, write a note to me, make up, Mr. Duick, I can't remember how to do part A. I'm going to make up a value for part 2. Let's suppose I got an acceleration of 5. Show me how you can do that for part B, and I'll give you full marks for part B. So if you're ever stuck on a part A, make up a reasonable value for part B, and you can still get the full marks for that. I will always do that. Find the acceleration of the following mass. Okay. This one's tough. Free body diagram. Oh, by the way, for part marks, it would be 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, forgetting the t by itself, 1 mark. mg. I know the normal force is not the same size as mg because I have an extra vertical force here. Is the normal force going to be bigger, smaller, or the same size as mg? I'm going to really exaggerate it so it catches my eye. We call this mystery force coming from off the page F applied. And there is friction. Who's winning? I think F applied. Who's losing? Friction. That equals MA. It wants me to find the acceleration. A equals F applied minus mu times the normal force divided by m. I don't know the normal force, and it's not mg. So somewhere I'm going to have to realize, am I sinking into the ground like quicksand? Am I flying through like Superman? Everything down equals everything. Everything down is mg equals everything up is normal force and plus 19. Oh, now I can tell you the normal force. It's going to be mg minus 19. Okay? If you crunched that, that's fine. I'm naturally lazy, and I would like to try and do this in as few steps as possible. So I'm going to go F applied minus mu, and then in brackets, mg minus 19, because that's the normal force. So it has to be in brackets all over m. So it's going to be 12 minus 0.48. 3.6 times 9.8 minus 19 all over 3.6. I'll fit it in here. A equals bracket 12 minus 0.48 times bracket 3.6 times 9.8 minus 19. Close off the normal force bracket, close off the top. Divided by 3.6. I think I typed this right. Do you get 1.16? What if I'd gotten a negative answer here? Friction's winning. It's slowing down. Okay? In Physics 11, you can get away with probably just making everything positive and negative. In Physics 12, you'll be doing complicated enough questions that you might have had friction pointing the wrong way, and so you might have to redo part of your free body diagram too. But if you get a negative answer, don't just ignore the negative. Stop, think it through, make sure you haven't made a silly mistake or a typo, but then go check your winners and losers. 1.16 units. Oh, Verizon's looking for more people. If you got that, 3 out of 3. Otherwise, I would probably go a half mark if I saw that. Half mark for dividing by m. A half mark for that. A half mark for the numbers, and then 1 mark for the answer. Number 3. Here's an example of kind of a medium multiple choicey question. Who's winning? It's got to be the 60. I think my equation is going to be winner minus loser equals MA. I didn't even do a full free body diagram because they kind of did the crucial part of it for me with those arrows. And I said, oh, you want me to find A? Divided by m. By the way, first thing I actually did was I'm accelerating to the left. I scanned the answers. Had anything here been to the right, I would have just crossed it out and saved myself the bother. Sadly, they are all pointing to the left. So I said it's going to be bracket 60 minus 36 divided by 12. I could do this in my head actually, but whatever. 2. B. 1 mark. Number 4, consider the following diagram. It wants you to draw the free body diagram clearly showing all the forces acting on M1. Okay. What are the forces acting on M1? Gravity. Bigger, smaller, or the same size as mg? What else? Bigger, smaller, or the same size as F applied? It is. How many arrows did I draw? How many marks is this worth? 2, half mark for each arrow, and I would look for these two to be the same size, and I would look for friction being smaller than F applied. Unless the question said, and is slowing down. If the question said, and is slowing down, which of these two arrows would be bigger? Friction would be bigger, right? Okay. Find the acceleration of the mass. Okay. A is going to be F applied minus mu times the normal force all over m. I don't know the normal force. Oh, you know what? Because this time the normal force is mg, I might be tempted to take a small shortcut and just do that. Instead of rewriting it, I don't need to go crunch it. So I'm going to get A equals F applied 225. I don't know what it is, but for some reason, when I put 225 here, many students write 255 here. It happened yesterday when I was helping a student, and that just jogged my memory that every year kids do that. I've even thought about changing this number, but I think it's more important to let you make the silly mistake and just say to you, you need to learn to read even more carefully on a quiz or a test, or double check or triple check. You'll notice I always check my calculator before I hit enter. Those kind of little habits are good ones to get. Minus 0.15 all over. What dumb mistake have I made? Can you see it? What? Well, a lot of people, oh, isn't that friction? No. That's part of the equation to calculate the force of friction. But it's going to be mu times m times g. It's mu times the normal force. So often I'll have a kid, well, isn't friction 0.15? No, it's much larger. Bracket 225 minus 0.15 times 100 times 9.8, close off the top, divided by 100. Do you get 0.78? This is barely accelerating. In fact, probably if I was drawing this to better scale, almost as long as F applied, but I'm not that fussy. That's why I said to you for free body diagrams, roughly to scale. And what I really mean is make sure I can easily tell which one's bigger, which one's smaller. That's more important. So what was it, 0.78? Meters per second squared. If you got that 2 out of 2, otherwise I would give you a half mark for that, a half mark for putting in friction, half mark for the numbers, and a half mark for the answers. Ooh, I like number 5. I like number 5. I like number 5. Number 5 is a nice question. Free body diagram, so I'm going to have M1G. I'll call it normal force number 1 to go with mass number 1. Looks like there's going to be a friction force. I'll call it friction force number 1 to go with mass number 1. And it looks like tension, no F applied or anything on the 6.3. It's getting pulled forward by the rope. What about the 4.6 M2G tension? Normal force? F applied? Mr. Dewick, wait a minute. 4.6 is smaller than 6.3. This can't move. Or can it? The tug of war is between that. And as long as this is larger than that, we'll move. We'll accelerate. I'm going to write an equation along the rope. Who's winning? It's going to be M2G, and then I'll have a minus tension. I'll have a plus tension. I'll have minus friction, not minus M1G. It's not along the rope. Minus friction force number 1. I do have forces from more than one mass on the left, so I better have M all more than one mass on the right. I get to relax. They want me to find the acceleration, so A is going to be M2G minus mu times the normal force number 1 all over M1 plus M2. I don't know normal force number 1. Oh, but look. Now, by the way, I'm not going to do this on a test, but I might next year on a quiz. Would this be much more difficult if I had an extra vertical force pushing down or pulling up? You'd have to calculate the normal force the same way as we did in question 2. But I would argue, Jaden, it's tougher. Sorry, it's longer. I don't know if it's that much tougher. It's just more typing. I can really muck around with these, and all I can do is stick more forces on them. Well, it's fine. Be more careful. I'm not going to surprise you with something like that on the test, but I'm making a mental note. I think next year on this quiz, I might add an extra normal force just for giggles. Since the normal force is just mg, well, you know what? Let's write it one more time. It's going to be m2g minus mu m1g all over m1 plus m2. And if I plug in my numbers, m2, 4.6 times 9.8 minus 0.19 times, what was it, 6.3 times 9.8 all over 6.3 plus 4.6. Could I go 4.6 plus 6.3 on the bottom and still get the same answer? Yeah, when you're adding, order doesn't matter. When you're subtracting, it does. So always be careful when you're subtracting. Brackets around the top, definitely. 4.6 times 9.8 minus 0.19 times 6.3 times 9.8. Fixed. Looks good. No, the 3 didn't show up. 4.6 times 9.8 minus 0.19 times 6.3 times 9.8 divided by, open up a bracket, 6.3 plus 4.6. And I get, built-in error check. I know the fastest mass 2 could accelerate in free fall is 9.8, so it's going to be less than 9.8. Hey, it is 3.06. Find the tension in the rope. Which mass would you use to find tension? I would use the hanging one. It's less cluttered. So it's going to, if you got that 4 out of 4, otherwise I would give you 1 mark for that. I would probably give you 1 mark for that. I would give you 1 mark for the numbers and 1 mark for the answer. M2G minus tension equals M2A. Swappy dance. M2G minus M2A, and I'm going to put the equals tension on the left because that's where we're used to seeing it. So it's going to be 4.6 times 9.8 minus 4.6 times, I'm going to use my answer button, but if you wrote 3.06, you're probably going to be okay because it's 5 nines, so there's not much rounding off going there anyways. 4.6 times 9.8 minus 4.6 times answer button. Do y'all get, 31 even? 31.0? No, yes? Yeah. And tension, it's a force, newtons. I would give you a half mark for that, half mark for getting the T by itself, half mark for the numbers, and a half mark for the answer. Yeah. If you got the wrong acceleration, but you went m2 times 9.8 minus m2 times your acceleration, I would give you 2 out of 2 for part B. Okay? And if you're not sure, show it to me later. When I say come lawyer with me, that's really when you want to start asking those questions, and I'll come look over your shoulder. Missing mass questions, normally I put on your test. This time it's going to be a bonus question, but here is a missing mass question. First it says, find the tension in the rope. Well, the only mass that I know is this one, so I'm going to do a free body diagram for this one. I have M1G, normal force number 1, tension. Is there friction? Is there an F applied? No. Which way is this 4.2 accelerating? To the, so who's winning? Tension. Who would be losing? Anything pointing to the left. Is anything pointing to the left? So you get this. Winner, no loser, equals, and I'm just writing an equation for mass 1, it equals M1A. So I can find the tension. It's going to be 4.2 times 3.2. And I get 13.44. Because I'm going to use this, I'm going to write all the sig figs. I would give you 1 mark for that, 1 mark for that, 1 mark for that. Now, looking at mass 2, I have M2G, tension. Which way is mass 2 accelerating? Down. Who's winning? M2G. So my equation for mass 2 is going to be M2G minus tension equals M2A. What do they want me to find? M2. How many M2s do I have? How many would I prefer? You know, it'd be really cool. Well, get them to the same side first. So I'm going to swappy dance. That's going to give me M2G minus M2A equals tension. How many M2s do I have? 2. How many do I prefer? 1. It'd be cool if there was a Math 9 trick that I could pull out of my back pocket. There is. There is a greatest common factor. There's an M2 in everything. By the way, if you're trying to jog your memory, it's like when you did stuff like this. If they said factor 5x squared y minus 3xy, you said, well, there's a y in everything, and then it's going to be 5x squared minus, there's a y and an x in everything, and it's going to be 5x minus 3. If you multiply that out, you'll get the previous line. GCF, greatest common factor. Holy smokes, who knew some of that was useful? So you're going to get M2 bracket G minus A. How would I get the T by itself? Or sorry, how would I get the M by itself? Yep. M2 is going to be tension divided by G minus A. It's going to be 13.44 divided by 9.8 minus 3.2. Answer button divided by bracket 9.8 minus 3.2. And I get 2.04. Is that right? If you got that, 3 out of 3. Oh, units, it's a mass. Kilograms. Okay. Otherwise, I would give you probably a half mark for that, 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 half mark for the numbers, and a half mark for the answers. Can you give yourself a lovely score on the top of this quiz out of 27? But I don't want you to hand this quiz in. Just hang on to it for a second. But anybody need to lawyer with me, now is the time.